Hello, this is Imran. I'm a PhD student in School of Civil Engineering and Environmental Science at University of Oklahoma. I am working with Dr. Sadri on the Transportation Risk and Information Commons Lab. My research focus on development of transportation resilience model against natural disaster for Oklahoma. I welcome you all to my presentation exploring the interdependencies between transportation and stormwater networks. The case of Norman, Oklahoma. This area of study has long been understudied, and due to this, the transportation as well as the stormwater networks are suffer. As a result, the urban areas are vulnerable to disruption against pluvial flooding event. Road network suffers from congestion, and the vehicle needs rerouting due to closure of intersection for flooding. We need to see the problem from systems perspective where the road and stormwater systems are connected. In fact, all the systems are connected in different manner. The connectedness gives the idea of interdependence of systems. In our problem, the road and stormwater networks are considered interdependent, so the failure from one infrastructure may cascade to another. The goal of this study is to investigate the functional and spatial interdependency of transportation and stormwater systems using complex network matrices. We represent the road and stormwater networks as graph and develop a multi-layer network to represent the interdependent and connected system. For this, we use the road and stormwater networks of Norman, Oklahoma. At first, we represent the transportation network as graph, and where the nodes are the intersection and edges are the road links. We use AADT as a weight of the edges. We also represent the stormwater network as graph, where the water inlets are the nodes and water conduits and creeks are treated as edges. We used Moran's eye to explore the spatial correlation, and we found that global eye value indicates significant relationships between stormwater and transportation network. Based on this spatial correlation, we define the multi-layer network where the transportation and stormwater networks are connected when the water inlets open into the roadway. We assume node-to-node connection better represent than edge-to-edge connection. Then we estimate the network matrices for transportation, stormwater, and multi-layer network. It is identified that the centrality values significantly differ from centrality values of multi-layer network is significantly different from the individual stormwater and transportation networks. It is found that the nodes with high degree values for three networks are close in residential areas but not in same place. Again, most of the central nodes of three networks are close in proximity but not in same place. In addition, centrality of road and stormwater and multi-layer network edges show tendency to overlap each other. Some of the key findings from this study are the spatial weight generated from local Moran's eye produces logical estimate of topological credentials. Most of the central nodes roads are identified in the local area, and most of the central conduits are identified in natural creeks. In general, topological credentials like the degree, the centrality values indicate the criticality of similar nodes and edges. One of the research challenge of interdependence of system studies to identify the vulnerable locations of cascading failure. This study indicates that the topological credentials of multi-layer network have potential to overcome this challenge. So the conclusion is that the multi-layer representation of system can be used to study the interdependence of systems. I'd like to thank NSF for funding this project. Thank you, everyone. Have a good day.